Today, we are all gathered here to listen from the horse's mouth how they scaled during the pandemic and how they dived in through the tough times. Before getting into the details, a few words about the community. This community reaches over 2,000 Fab Labs in 126 countries, over 3,000 participants, which are makers, eco-friendly designers, industrialists, artists, teachers, researchers, and more. This maker event, the Fab 16, brings together members of the International Fab Lab Network, as well as government officials, academic researchers, and experts in the field of digital fabrication to present, envision, discuss, and build community around the digital fabrication, technology, and innovation. What did we miss this year? Yes, of course, the physical presence, but nothing can stop us. We being the tech tribe, we are going virtual this year. This year, Fab 16 is conducted online and in India, and we are hosting various interesting and interactive workshops and events. Today, we have with us Vaibhav Chhabra, who is a mechanical engineer by education, but a carpenter by passion. A graduate from Boston University, founded Makers Asylum. Makers Asylum is a community space focused on fostering innovation through hands-on learning. It provides access to an ecosystem of stakeholders, which includes governments, businesses, incubators, accelerators, investors, and subject matter experts. The space houses various labs that are co-located in order to facilitate prototyping of ideas that are interdisciplinary in nature. He is also the chair for innovation and entrepreneurship at Young Indians, Confederation of Indian Industries, and global shaper at the World Economic Forum. In today's session, he will share his learnings from M19 initiative of how they managed to scale from 0 to 1 million face shields in 49 days across 42 cities, towns, and villages, and also how to manage the quality checks and quality assurances in a distributed manufacturing and decentralized assembly lines so as to make locally for the local ecosystems. Without further ado, Fab Lab Kerala under Kerala Startup Mission takes proud in welcoming Mr. Vaibhav Chhabra to the session. Mr. Vaibhav, please.
Thank you so much, Sani. That was very nice of you. You've pretty much taken a very big introduction. So thank you. It's nice to be here. Hey guys, nice to see everyone. I'll quickly share my screen. I've put together a few photographs for you guys so you can see and follow along as I share. Real quick background, like Shalini mentioned, I'm a mechanical engineer, love carpentry. I was in Boston for about 6 years, studying in Boston University and then working at MIT Media Labs with Professor Ramesh on an eye diagnostic startup called iNetra. Back there, we had access to a lot of amazing makerspaces, fab labs, and of course, the MIT labs, which really helped to get making and learn pretty much a lot of my skills over there. And then moved to India and eventually started Makers Asylum about 8 years back. And since the past 8 years, we've been running around and setting up this community makerspace in India. It started in Mumbai, and now we're in Goa, just to put that into context. All right, so today the agenda is to talk about how to scale almost anything. Now, this is a very big topic and a slightly ambitious topic, and I'm going to try and sort of decipher some of our personal learnings and some of the learnings that we've gotten together, thanks to the Fab Foundation and others, to decipher what we did and how to apply that to many other projects. So hope this is valuable. Let's go. Scaling stuff is hard, and I think you guys would know this better than anyone else. I've got a few products and projects with me over here as well, so I can show you. When you're trying to design something, especially like electrical, some stuff with electronics in it and electronic housings and things like that, it takes a lot of time to be able to not just get the design right, but really to understand what is the requirement for this, whether it's going to be manufacturable or not, what is the batch size going to be, how wide are you wanting to scale this, what's the kind of budgets do you require, what's the kind of certifications you require. There is a lot of stuff that goes into going from a simple, fun prototype to something that you scale and something that you take forward into the market. Uh, and it's a long journey, honestly. And some of you might have gone through this, but some of you might not have. And that's okay, because that's the part where this community of the Fab Labs ecosystem really, really helps out. Personally, I was working, like I mentioned earlier, with the startup called iNetra about almost now 10 years back. And this started at MIT Media Labs in Boston. At least 100 prototypes. I don't know what this is saying, but okay, I think it's working. So we went through almost about 100 prototypes before we got to somewhere where we started to manufacture, or when we created our first sort of pilot of 200 units or 1,000 units. But it took us about 100 prototypes to reach that. It also took almost 5 years of research and development. That's a long time thinking about it from a product life cycle, right? Because products, when they come to the market, they last for about 5-10 years before the industry also evolves. So to be able to think something which is 5 years ahead and having that 5-year lead time to be able to prototype, to develop, to be able to create, and then get to manufacturing, there's a lot of stuff. Plus, there is money involved. There is a lot of certification involved. There's a lot of different things involved into going from an idea or a prototype into a product. How do we scale faster, better, cheaper is the big question, right? How do we do that in a more exciting way? Now that we have access to all of this technology, and we have access to the internet, and we have access to communities internationally, how do we do that? So for over here, I wanted to share our personal journey of Makers Asylum and what we did. Post that, what I will do is I will try and decipher some of the lessons from our learnings for you guys, so that maybe we can try and apply this to many other things. So we run a makerspace over here called Makers Asylum. Like I mentioned, it's a community makerspace. It's a fun space with all sorts of tools like 3D printers, laser cutters, carpentry, welding, electronics, pretty much everything. Think of it like a gigantic space with everything. And now we're in this beautiful 100-year-old Portuguese house, heritage house in Goa. So whenever you guys come to Goa, please do stop by and say hi. But what we primarily focus on is a lot of educational programs, and we've been doing them for almost about 8 years now. And we were doing them digitally. We do them with a lot of universities in Australia, in Europe, in India, pretty much everywhere. And it's been fun. And Makers Asylum has been known as the innovation hub of the country for a while. And all the nice word that's been spreading. But however, when the pandemic hit, just like everything else, we had to shut down. And I think some of you guys also face the same issues, right? Shutting down a physical space is hard. What do you do? So for us, just to give you guys a perspective, we were based out of Mumbai, and we had almost a 10,000 square foot facility in Mumbai. Now, for something like that in Mumbai, that costs a lot of money in rent. And it's almost comparative to like Manhattan rent. It's that crazy in Mumbai. So when the lockdown happened, we didn't know what we were going to do. We were super scared. And for a makerspace that are hardly sustainable, I mean, Makers Asylum has been a self-sustaining makerspace since the beginning. It's been bootstrapped and self-sustaining. We've been doing fine. But in a lockdown, how do you survive a space like Makers Asylum? I mean, such a big fab lab without any funding, without any university. We have to pay rent. We have to pay for our electricity. We have to pay for everything and our salaries. So we were in a little bit of a tough situation. So we didn't know what to do. But then what happened next was super exciting. So all of us, including myself and the rest of the team, decided that there's no point of going back home, because what are we going to do at home? Rather, let's stay over here at Makers Asylum, quarantine over here. It'll be more fun because we'll be around our tools. At least we can do something. Plus, we can try make some online content or do something. So with just that basic thought of not knowing, we decided to just pack our bags and move inside Makers Asylum and quarantine at the facility. And then we started realizing how scarce the situation was outside of Makers Asylum when it came to PPE equipment. And I think all of you guys heard about that because most of the PPE equipment for the world came from China. So nothing was coming to India, nothing was coming to many other countries, and everyone had to get started and start making. So we started. Within 2 days, we had a few prototypes ready of our first few face shields, and we started sharing them online with the open source community and sharing our designs and asking for guidance and help, and at the same time, if anyone wanted them. What happened next was super exciting because we started getting calls from all the local hospitals, from police personnel, from the government, from everywhere, asking us that, hey, we need these shields. How do we get them? So we started making. We didn't know what to do next. So 3 of us sat down on the chair and we said, okay, we're going to make. So we started making, and we used designs which are laser cut instead of 3D printed. So it was much faster. You can also see them behind me, all the prototypes that we went to. I'll talk about that later. But we started using laser cut designs, using locally available materials to be able to make them faster, better, and cheaper compared to 3D printing, for example, which is a little slower. So that allowed us to make about 1,000 plus face shields a day at Makers Asylum. So 1,000 to 1,500. So we got to work, but it also required assembly and some post processing. So the rest of us were just sitting over there, wearing our entire face shields and mask and getting to work. But it was limited. So we asked for volunteers to come in. We asked for volunteers, and over 20 people showed up. And they also bunked in with us at Makers Asylum. So now we had like 20 people living at Makers Asylum and building, which was quite exciting. So from there, what happened after that was that these people who were there, along with the people who are finding out about us digitally through social media networks, started joining in other cities as well. So a big, interesting community sort of started forming. Very quickly, we went through 21 design iterations, going from a paper prototype to making face shields out of wood, which we realized is a very, very bad material very quickly. And it's brittle. Commonly available in stationery shops in India and used for marketing, happens to be waterproof. Situation before injection mode, using a material called sunboard, and the ethical communities of the hospital started to approve it and they liked it. We also managed to get the Maharashtra tender for the same, which allowed us to really scale fast. But there was a problem. We had this community growing, but the supply chain was completely choked up. What I mean by the supply chain being choked up, there weren't flights running, there weren't regular cabs running, nothing was running. So we couldn't find, how do we transport these from one place to another? Very hard, right? How do you do that in the pandemic? And it's also not a good idea to be transporting them in a pandemic, honestly. So hospitals were sending their ambulances, like you can see. We had multiple ambulances always parked outside Makers Asylum. We had different kind of vehicles coming in. We had police vans. We had, those vans that carry prisoners. We had those vans coming in, and we were just loading all of them up with face shields, and they were heading out. But that wasn't very sustainable. We needed to find a better way to be able to manufacture in a more distributed network. And that's what happened. Slowly, over 42 cities, towns, and villages started joining the force. And that led to something called the M19 Collector. M19 stands for Makers Fighting COVID-19. And slowly, all the people that maybe knew us, maybe didn't know us, plus people that wanted to help out, started getting together in all parts of India. We practically had the east, west, north, south of India covered. And people from all over, I'm talking Kolkata, Bangalore, Pune, Delhi. So this is like vast varieties of India. Everyone started joining into this movement. and working together to create face shields at that time. Collective. This yellow line is Makers Asylum that started around the 24th actually, but okay, fine, it's starting from the 29th. And then after that, slowly, more labs started joining over the days. You can see the Makers Asylum was consistent, but the other labs, some of them were faster than us because they were using different technologies. And that was great because we got to learn from them to see how we can go faster. And that was amazing because we were getting different perspectives into the table, different communities, different people. As people joined, the force started to multiply. And that's what happened. We went from 0 to 1 million face shields in 49 days. And to just put that in perspective, it took us 15 days to get from 0 to 100,000 face shields. Then it took 7 days after that to reach the next 100,000. And towards the end, like you can see around the 14th and the 15th of May, we were almost making 100,000 face shields a day. So if you see, that was almost becoming an exponential curve over there. And that was really exciting for a bunch of makerspaces to be able to do that kind of impact. This map just sort of shows once again, like pretty much all villages in Maharashtra, other small cities were all joining across the country, which was exciting. What was also exciting was that this group was completely interdisciplinary. Now, you guys know the meaning of interdisciplinary. The fact that people were coming in from all different walks of life. These guys were not just makers. The youngest member of the M19 Collective was in a city in India called Gujarat, and he was 12 years old. And he made over 340 face shields with his family at home. We had filmmakers, we had media personnel, we had doctors. We had 3 doctors living with us at Makers Asylum. Now, these doctors weren't, since the beginning. So these were doctors that were not very active during COVID. So they were like, one of them was a neuropsychologist. Another one was a child specialist. So there were interesting doctors as well who were not active at that time, who were living with us and working with us. So that really helped us like keep motivated and keep working. And that's how we eventually made it to the million. But what was also exciting was there were very interesting different use cases of the shields that we also did. We made baby shields. We made superhero shields. Now, the superhero shields were inspired by open source medical supplies. There was a guy in Boston who was making them. We started sharing designs and started working on it together. The reason why we did that is that they're amazing for teenagers, because think about it. Teenagers were finding it difficult to wear masks and step out. But this was giving them a little bit more motivation, because last year things were great. We also made rebreathers. So that's one of the prototypes of the now in production rebreather. But that's the rebreather, which is sort of meant for senior citizens. It pumps up air into their mask directly so they can breathe more easily. We also made active respirators, which we never got through certification, but we did build them. This we did with a hospital in India called AIIMS Hospital, All India Institute of Medical Sciences. So some of you guys know what an active respirator is, but basically, I can stop my screen share so I come on full screen, and so it looks something like this. So you have air, so the filters go on the top, air comes out and goes directly into your hood. So you're basically getting filtered air all throughout your time in the ICU, I guess. These are the smaller rebreathers, which are primarily meant for senior citizens, so they can just hook them up on their hand and it pumps up air directly into their mouth. So it's sort of like a very simple draft of air that comes out of this, approximately about 5 to 6, no, actually about 3 to 4 LPM. So pretty low, just to sort of filter out the air inside your mask. Okay, going back to sharing my screen. All right, so then after this, what happened was very exciting. So obviously there was a lot of press and media attention that was catching traction. Then the University of Cambridge reached out to us, and there were a few researchers over there under Professor Jaideep Prabhu who reached out, primarily Lucia Corsini. They reached out to us. They were like, hey, you guys are doing some very interesting stuff. We would like to study it. So they started studying what we were doing. And there are a few research papers on this. You can find them online. Just search for COVID-19. That's a great case study written about this. So what happened over here? The M19 face shield scale so fast. So the fourth thing that came out, now I'm just going to go over this with you. Number one, purpose driven. The fact that so many different organizations and people from different walks of life came together to be able to make this, that means they had a common purpose. And that's very important. Having a common purpose as to why to scale. Now, this common purpose could be anything. Maybe it could be even money, or it could be something else, or it could be saving the planet with saving the fossil fuels. It could be about climate change. But having a common purpose to the product that other people also resonate with really helps to be able to create that community and create that passion or purpose towards other organizations to also align to start working on the same thing. The other thing was communicate external impact. The other thing that we were doing all throughout was that we were constantly communicating as to what each of our numbers are every day and what is the overall tally. What's the bigger number that we have all done together? How close are we getting to the 1 million mark? That kept each of the other organizations motivated. So communication of impact is super essential in sort of continuing to get that motivation through the other labs as well. So some sort of involvement over there is important. The other one, easy knowledge share. That's super duper important. You need to make it super easy for other people to copy, as counterintuitive as this sounds. Good documentation over here. And you guys are here at Fab 16, so you know the meaning of documentation. Good documentation is a very, very important thing for making it easy for people to replicate. And that's what we can pass on, right? Structure to communicate locally. Now, that is actually very, very important, because what we did was not that we were communicating for everyone. What we did is we created local hubs. So the moment we identified a few key people in a city, let's say called Jharkhand, we connected all the people in Jharkhand to each other and allowed them to communicate independently from the main hub. This is very important because while you are connected to the main hub, you have your own smaller hub that's communicating. Very similar to the Fab Lab ecosystem, right? If you think about it, you have one main nodal at MIT, Center for Bits and Atoms, but then you have all the other Fab Labs, which are city-based and township-based, which acts as local hubs. So you communicate more with the local hub, and then you communicate with the major one. So similar structure that really, really helps in allowing smaller city-specific problems to get solved and local problems to also look at. Okay, and the most important part, open versus closed innovation. In a closed innovation system, when you're trying to preserve IP and things like that, for example, in the case of iNetra, the organization that I was working at, we were obviously a funded startup that was looking at creating this device and holding the IP. In that case, what happens is when you have that big idea that, oh, I can test eyesight using a phone, you need to design, analyze, build, and test all internally. So you need the right kind of people in your organization to make this and continue to prototype, analyze, and test. It goes out in innovation ecosystem. For example, the Fab Lab ecosystem or the Makers Asylum ecosystem. When you have an idea, you're able to share it with all the other labs. So that idea becomes a bigger idea. And then you are able to design with all the other labs. You're able to get inputs from the other labs onto it. You're able to analyze faster. You're able to test faster. You're able to build faster. what that does is two very, very important things. One, it really reduces the amount of time spent in R&D. A lot of it. The cost that's going in is actually to think. So all of that cost that's going in gets really, really compressed when you distribute that. And other labs can also contribute because you're always then innovating faster, leading to a successful solution, which is faster, better, and cheaper in most cases, or in some cases at least. So while this was happening in India, and you guys, there were 4 supplies that were delivered internationally by the maker community. $271 million worth of medical supplies were created by the maker community. That is amazing. That just shows what was happening with the 1 million mark in India was happening all across the world, and the doing exactly manufacturing, sharing ideas. There was one key problem. The problem that how do you manage quality assurance and quality?
Vaibhav, I think we lost you.
I think we have lost the Vaibhav in between.
Yeah, I think he will join. I'll ping him.
Okay.
Offline. Yeah. Okay. I think he dropped and he'll be rejoining in a minute. Is facing some network issues. He'll be back in a minute.
I apologize. Can you hear me?
Yeah, Vaibhav, loud and clear.
Hello?
Yeah, you're
Nadeem, can you hear me?
yeah, Vaibhav, you are audible. Like,
Okay.
loud.
Really apologize for that. Resharing my screen. Thank you. Hopefully we didn't lose too many people. Okay, getting back. So the problem over here was quality assurance and quality checks. So some of you might heard about this problem, but the problem is that when one lab is making something and another lab is making something, are they following the same kind of quality checks? Are you able to share the same certification or validate that the same kind of thing that's being made in another city or town or village has the same standards, especially because these are supposed to be lifesavers in certain ways. In the case of the face shields, however, they were not as high risk as, for example, the Papa. So it flew for some instances. However, we realized the problem pretty early, which is good because that means that we could address it. So we tried to do the same exact thing this year when it came to oxygen concentrators. We realized in India, maybe some of you guys would have heard about this, especially the guys in India. India went through a very, very acute oxygen shortage. And there was a huge problem because there weren't enough oxygen cylinders, there wasn't enough oxygen being created or produced. So, and a lot of people died because of that, which is very unfortunate. And there are devices called oxygen concentrators which exist, but again, they aren't manufactured in India. At least as of last year, they were not, just like face shields. So we took up the problem, we took up the challenge. We said, okay, fine, we're going to figure out how they work and we're going to share that knowledge with the rest of the world so that other small manufacturers can quickly start making. So the M19 Collective can start activating. Our job as Makers Asylum, as a makerspace, would be to be their R&D lab, to give them all the support in terms of the knowledge. We did not plan to manufacture them, but we plan to share knowledge. That was our motivation behind this campaign, and that's what we did. So we studied all the open source designs that were out there. There was, of course, the OxyKit, there was the Maruts, there was the Apollo. There were multiple designs that were created across the world and open source, which are available in the open domain. There still are, and they're still work in progress. But however, none of them were manufacturing ready. That means that none of these designs that's actually out there would pass certification. So that means there was still work to be done. There was still R&D to be done, especially related to the Indian market and the Indian context. So what we realized very, very soon is that India being a tropical climate country, the biggest issues that oxygen concentrators faced in India that were imported into India were two things. One, temperature, which caused higher humidity any which ways. So sort of related, and humidity. The humidity, for example, in Goa at the moment is about 90%. That's a lot of humidity. I mean, I'm sweating in a room because it is humid over here all the time. And that's not very good for the zeolites in the oxygen concentrators because they become like cakes inside it, especially in that pressure with moisture, they completely get ruined. So, and they lose their nitrogen absorption capacity, which is obviously not good because that means that if the nitrogen absorption capacity drops, that means the oxygen delivery capacity also drops. So we needed to figure out ways on how we can sort of take the open source knowledge which is there, remove the moisture out of the equation somehow by drying the air, and then create a version that works especially for the Indian climate. So we got to work immediately. We started ordering the parts, we raised a crowdfunding campaign to raise some funds, and then we got all the parts necessary to start building. We started with the OxyKit project, and then moved on into prototyping our own versions. And we went from version 1 to version 2 to 3 to 4. And now it looks something like this that you can see on the rightmost part of the screen. And at the bottom of the screen, it's packed up, it's sound insulated, it's got all the things necessary for giving us a 15 liter per minute at 90+% oxygen concentration. And we sent this for certification now to a testing lab. We tested it enough at our lab, and now we've sent it further to a testing lab to get certified so that we know for sure that this thing is good to be given to patients, for example. We tried a lot of things to get rid of the moisture. This example that you can see on the top is actually a refrigerator system. We tried moisture separators, we tried refrigerator systems, we tried a PSA system attached to another PSA system to remove the oxygen. We tried a bunch of stuff. And finally, we decided to stick to sort of like a refrigeration system that cools the air, and then a moisture separator that takes out all the moisture before sending it into our zeolites. And that was the most economical and works. What was exciting was that over 30 other labs in India were able to follow what we were doing parallelly. Parallelly, thanks to documentation, which is on GitHub. You guys can also access it. And regular calls. So we earlier were doing one call every day. That was too much, I think. Now we do one call every week because now everyone's a little bit more independent and they know what they're doing. 2 months back, we all did not know how to make oxygen concentrators, but now we do. And that's awesome because we've learned a lot and we've shared a lot. But this time, it's a very, very key focus on QA and QC. So the Management Technology Policy Department for Engineering at University of Cambridge officially came on board this year. They're actually funding the project as well. They are supporting it, helping us with certification and other things. But the Professor Mukesh and his students, his PhD students, researchers, Professor Jaideep, there are a few professors and PhD students that are working at Cambridge University now with us to be able to look at how we can crack this. Because if we can crack it with one device, we can crack it with many others. If we can crack the quality assurance part across other labs. So that means that if one lab gets certified, how do we make sure that all the other labs are also doing the same exact things with a certain range, allowing them the flexibility to use different paths, but also use the same certification perhaps. Things like that. So we're working with ISO, we're working with the University of Cambridge, we're working with the Fab Foundation. Professor Neil has also been helping us out quite a bit on this project by connecting us to people, supporting it in every possible ways. We've been presenting every few weeks on update calls. So it's been quite exciting, honestly. It's a challenging problem, but if it can be done for 1 or 2 projects where you can also scale like the quality assurances and quality checks, that would be a really, really good thing because then you can almost scale anything. And even now you can, to be honest, with the same sort of process without without healthcare devices though. Healthcare devices, you need a lot of QA and QC, but other products is super easy to scale now thanks to this community that's put together in front of you and you can use it. So that's about it. That's what we do now. We continue to share knowledge. We are still building capacity for open innovation. We are doing a lot of calls and other things and sharing everything that we know about the oxygen concentrator and other projects openly to be able to keep building this open ecosystem in India as we progress. Couple of key takeaways for you guys in a snapshot on how to scale almost anything. Here are my thoughts. Number 1, open source thought process. It really helps because then you're always open about sharing. Number 2, sharing knowledge is much faster than products. You got to remember that. Just like the Center for Bits and Atoms, you can share bits much faster than atoms. And that's because of the internet and technology. We can't share atoms as fast yet, but we can by sharing bits that convert into atoms using digital manufacturing tools, for example. And that's why that's really cool. So using knowledge that you're sharing is better in this sort of a case. Finding a strong purpose is also really, really important. It could be crisis, it could be wealth, it could be demand, it could be electric vehicles, whatever it is. But the point is, having that common purpose really, really is important, because that's what helps other organizations and other individuals to align with your thought and your project. Documentation is key to scaling. That's again going back into knowledge piece. Understanding manufacturing processes to innovate faster. That's also very important. Knowing from the beginning what it means to scale is really, really valuable when you're making your prototypes and when you're designing your products. Having an interdisciplinary group leads to faster innovation and scaling. Yes, having people from different backgrounds, even kids, they're awesome. Having a 12-year-old into the M19 Collective was amazing. We got to learn a lot from him. And that's the point of it. You learn from everyone. You learn from different backgrounds, you learn from different theories, you learn from different people. And that's what helps you scale faster. Thank you very much. That's about it from my side. Happy to, if we have some time, happy to take some questions. And thank you, Nadeem. Thank you, Saloni, once again for having me.
It's our pleasure, actually. We'll now open for the Q&A. We have a few questions in the chat box.
Oh, yes, looking at it now. How about the economy of scale? Did manufacturing methods used for M19 benefit from this? Yes, of course. When we started, obviously, we were using something like laser cutting, which is more expensive than, for example, injection molding that we use eventually. And you can see that over there by the time we got to injection molding. When we were laser cutting, we were already pretty cheap, to be honest. We were able to laser cut and make them at about 20 rupees a piece. That's approximately maybe 25 cents, a little bit more. Yeah, somewhere over there. So we were able to really make them cheaply using laser cutting, because laser cutting is already a valid industry in India. So using that, we were able to scale by sort of piggybacking on an existing industry. And then, of course, when economies of scale come in, then you were able to benefit from that too. We were able to reduce costs as we go along. And over when we were making in the hundreds of thousands with injection molding, for example, towards the end of the initiative, because it takes time to make a mold and then all of that, we were able to benefit from that. If you want to join with the making, what should we do? Well, I will throw in some links over here, if you allow me. So you can go to Makers if you want to join the M19 Collector. It's pretty straightforward and easy, especially. Here you go. Here's the link for the M19 initiative. And then you can also check out the link for the M1902, which is the oxygen concentrator project. And also on the M19 initiative page, you can check out the Shields page, which was right here to get all the details. So the website, we are actually working on building our website as well. So in a few days, the website will be updated, possibly by next week, with much more information and many more photographs and many more things. So check back again next week as well, if you can. How to convince parents that we are thinking and doing is of real worth necessary for our coexistence with nature? Hey, I like this question. Who asked this? Shubha. I'm still trying to convince my parents, honestly. they are half as confused, and most of the times they don't know what I'm doing. So if you figure out an answer for them, I will ask you too how to answer this, especially if you have Indian parents over here. I am watching the program from Bhutan. Is it possible for makers in our country to join you? Yes, of course. We have people in Indonesia, in other parts also working on the M19 initiative. You can check out over here, and then I'm happy to add you guys to the Telegram group for the M19 initiative as well, so that you can keep up to date. And if you're building the concentrators and other things, we'll be able to give you all the information faster. But when you go to the M19 initiative page, and especially when you go into M1902, there is a big button right in the center that says join the M19 Collective. You click on that, you fill in the details, and you'll get added. You'll get an email and get added pretty quickly. We'll make sure that happens. Okay, I think I answered all the questions. Thank you, Nadeem. Thank you, Salni.
Yeah, I think we have one more question here from Sibu.
Okay, I really believe in open knowledge, importance of open source projects, but people ask questions about making money, recovering the R&D costs. How to tackle based on your experience? I think money comes, and I've seen this in my life. It's kind of weird, but I'll just tell you this. Makers Asylum started in a small garage. We didn't have money to buy equipment. We didn't have money to rent a space. But then the space came to us for free in Bombay initially. And we also got tools from all different organizations. As long as you believe in what you're doing and you keep doing it, there are different ways that people support you. It's kind of interesting and weird at the same time. We kept asking and we kept doing it. And it comes from interesting ways, honestly. We have been running for 8 years sustainably. We don't have an organization funding us, one specific organization at least. We keep trying new things, our courses, our programs. It works. It's probably not as straightforward as manufacturing, where you manufacture, make, and sell. It's not that straightforward thunder where you're just sort of transacting. It's not that transactional business. And we tried that honestly for some time. It did work for us. We did not like it. So I like doing this. So when it comes to R&D, there are different ways of making money. For example, in the case of the shields and in the case of the oxygen concentrators, initially we started by using crowdfunding money, and we applied to a lot of grants. And actually also Makers Asylum Foundation also gives out grants for R&D now, starting this year, because we like to support other makers as well while we get support as well. So that's another thing that we're trying out, is that we are working on applying for some bigger grants, because this year we got funded by Schmidt Futures, which is Eric Schmidt, Google founders, Google basically, their foundation. They funded us for some of these projects to work on building this network. So what we're doing is that with them, we're trying to work together on sort of supporting more maker spaces across India, especially for R&D costs and things like that. So we're going to be opening out that portal as well, because R&D is important, and there needs to be more investment into R&D. So yeah, it's difficult, but at the same time, what I want to say is that the funds come from different places, different things that you might not even expect. But as long as what you're doing is what you believe in, money makes it your way when you need it. Sorry for being ambiguous. Sivu, does that answer your question? Maybe.
It's answered so many questions, so many else had in mind, I believe. So it's not only the passion, the R&D, so everything, you sum it up as like this, what Paulo Coelho has said, whatever you really want, the universe will bring it to you, right? So it's
Yes.
yeah. So, and thank you for sharing the wonderful journey and experience what MI19 Collective Community has. It's a purpose-driven, the easy knowledge sharing, the communicate which impacts the externally should impact it, and the structure to communicate it locally. Everything was very informative. Also, how wonderfully you have explained the closed innovation and how open social innovation will bring in the solutions to scale exponentially. Thank you so much. And when it comes to success, it is not an individual, it is not the team, it is a community. And especially when it's a community where people with the same tribe or the same thought process or the same interest level is there, it can create wonders. So thank you so much, Vaibhav, today for sharing your experience with us and the journey and how everything was structured perfectly well. And I hope all the participants got to interact with you through the Q&A. So thank you so much. So we will look forward to have more sessions with you as well.
Thank you so much for having me. It was a pleasure.
Thank you so much.
Take care. Bye.